To convert the Hello World application to a to-do list application, we begin by adjusting our data types. The to-do data type represents a single item with a text field for its name. We also need to import the text type from data.text. Our state will no longer be unit, but a data type holding a vector of to-do items. This means we also need to import vector from data.vector. As the run function returns the last state value of the state reducer loop, we need to discard that return value in main. We wrap the run action in void. Let's rewrite our view function. We changed the title to TodoGTK and replaced the label with a to-do list, which we'll define in a where binding. We use container to declare a GTK box with vertical orientation containing all the to-do items. Using fmap and a typed hole, we see that we need a function from to-do to boxChild of event. The to-do item will render a to-do value as a GTK label displaying the name. Now, GHC tells us there's a non-type variable argument in the constraint. The type of to-do list requires us to add the flexible contexts language extension. The remaining type error is in the definition of main, where the initial state cannot be a unit value. We construct a state value with an empty vector. While our application type checks and runs, there are no to-do items to display, and there's no way of adding new ones. We need to implement a form, where the user inserts text and hits the enter key to add a new to-do item. To represent these events, we'll add two new constructors to our event type. To-do text changed will be emitted each time the text in the form changes, carrying the current text value. The to-do submitted event will be emitted when the user hits enter. When the to-do item is submitted, we need to know the current text to use. So we add a current text field to the state type. We modify the initial state value to include an empty text value. Now, let's add the form. We wrap our to-do list in a vertical box containing the to-do list and a new to-do form widget. The form consists of a GTK entry widget with the current text of our state as its text value. The placeholder text will be shown when the entry isn't focused. We use onM to attach an effectful event handler to the changed signal. The typed hole tells us we need a function from GTK entry to IO of event. The reason we use onM is to have that IO action returning the event, instead of having a pure function. We need it to query the underlying GTK widget for its current text value. By using entry getText and mapping our event constructor over that IO action, we get a function of the correct type. It's often necessary to use onM and effectful GTK operations in event handlers, as the callback type signatures rarely have enough information in their arguments. But for the next event, to-do submitted, we don't need any more information, and we can use on to declare a pure event handler for the activated signal. Moving to the next warning, we see that the update prime function is no longer total. We are missing cases for our new events. Let's give the arguments names and pattern match on the event. The case for closed will be the same as before. When the to-do text value changes, we'll update the current text state using a transition. The first argument is the new state, and the second argument is an action of type IO of maybe of event. We don't want to emit any new event, so we use pure nothing. For the to-do submitted event, we define a new to-do value with the current text as its name, and transition to a new state with the new to-do item appended to the to-do's vector. We also reset the current text to be empty. To use vector.snock, we need to add a qualified import. Running the application, we can start adding to-do items. Our application doesn't look very good yet, so let's improve the layout a bit. We'll begin by left aligning the to-do items. To push the form down to the bottom of the window, we'll wrap the to-do list in a box child and override the default box child properties to have the child widget expand and fill all the available space of the box. We rerun the application and see it has a nicer layout. There's one very important thing missing: being able to mark a to-do item as completed. We add a bool field called completed to the to-do data type. When creating new items, we set it to false. Instead of simply rendering the name, we'll use strike-through markup if the item is completed. We define completed markup, and using guards, we'll either render the new markup or render the plain name. To make it strike-through, we wrap the text value in S tags. For this to work, we need to enable markup for the label by setting use markup to true. And in order for the user to be able to toggle the completed status, we wrap the label in a GTK check button bin. The active property will be set to the current completed status of the to-do value. When the check button is toggled, we want to emit a new event called to-do toggled. Let's add the new constructor to the event data type. It will carry the index of the toggled to-do item. To get the corresponding index of each to-do value, we'll iterate using vector.imap instead of fmap. The pattern match on events in the update prime function is now missing a case for the new event constructor. Again, we'll do a transition where we update the to-dos somehow. We need a function from vector of to-do to vector of to-do that modifies the value at index I. There's no handy function like that available in the vector package, so we'll create our own. Let's call it map_at. It will take as arguments the index, a mapping function, and a vector of A, and return a vector of A. We implement it using vector.modify and actions on the mutable representation of the vector. We overwrite the value at I with the result of mapping f over the existing value at I. To use mutable vector operations through the mvector name, we add the qualified import. Finally, we implement the function to map called toggleComplete. Now, we run our application, add some to-do items, and mark or unmark them as completed. We're done. Building our to-do list application, we have learned the basics of gi-gtk-declarative and the app simple architecture. There's more to learn though, and I recommend checking out the project documentation. There are also a bunch of examples in the Git repository. Please note that this project is very young, and that APIs are not necessarily stable yet. I think, however, that it's a much nicer way to build GTK applications using Haskell than the underlying APIs provided by the auto-generated bindings. Now, have fun building your own functional GTK applications.